There's yttrium, terbium, actinium, rubidium, boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium.
Welcome to the first video of the ethylene and addition polymer chapter. What I'm doing in this video is cover the first dot point, which is actually a relatively important dot point, and it's all about chemical reactions. I'll read the actual dot point. It says, construct word and balanced formula equations of chemical reactions as they're encountered. And before I start, I quickly want to talk about that word chemical reactions and what exactly it was again. And when it comes to this actual whole chapter, there's a lot of different chemical reactions that you encounter and a lot of different chemical equations that you have to remember, and formula equations. But I'll go over just some of the big ones that are introduced in this chapter and in this module. So for example, if we go from oil to plastic, that is one thing that we encounter, production of polyethylene, for example. But how does it work? So how does this happen? I mean, this is a pretty big sort of jump from oil, which is a brown, blackish liquid, to a plastic. And that's where these chemical equations come into play. These chemical equations help us to be able to visualize the steps that are involved to go from oil, in this case, for example, from a fraction of oil like decane, to eventually a plastic itself. Now, the actual chemical equations, you should view them as a sequence of chemical equations. So, for example, when it comes to going from oil to plastic, it doesn't happen in one chemical equation or in one chemical reaction. It happens over quite a few different ones. And what exactly was a chemical reaction again? A chemical reaction is when you have things reacting together, different substances reacting together, and forming new substances, new compounds. So, for example, ice turning into liquid water, that's a physical reaction, not a chemical reaction. Whereas in this case we have oil, which is really different to plastic. So obviously there would have been some chemical reactions going from oil to plastic. And the same thing going from, for example, trees to paper. Right? So trees to paper, there are some chemical reactions involved to go from there to here. And same with going from corn to ethanol. So going from corn to ethanol, there are very different substances, so there must have been some chemical equations, chemical reactions to go from corn to ethanol. And what we'll do in this video and in all the videos to follow is go through them and just show you how this actually works. So how does this happen? So how do we go from one substance which looks completely different to something which is completely different in properties and from their appearance wise, and how that works. So I want to start with this one. So how we actually write these chemical and formula equations. So first important part, I'll put that down as number one, is always to list your reactants. I'll write R plus P, so that's reactants plus products, because reactants are the things we start with and products are the things we end up with. So these reactants will undergo a chemical reaction and produce new products. In this arrow here is our chemical reaction. So if you see one of those arrows, that means that a chemical reaction actually happened. Now, I'll give you an example. If we have our oil, which we can call, in this case, let's call this decane. And decane is actually a fraction of petroleum, of oil. And decane can go into something called ethylene. And this could be ethylene. Now, ethylene is a gas, and decane is a liquid. So liquid for decane, as you can see, and ethylene is a gas. So another important part that we always have to make sure when it comes to chemical equations is list the state of matter. And what I mean by that is, what is it? Is it a liquid, a gas? Is it aqueous? That means dissolved, or is it a solid? So in this case, for example, with these examples, we had decane, which was a liquid, and that turns into octane, which is a liquid, alpha liquid, and ethylene, which is a gas. So make sure to put those states of matter. So as I mentioned earlier, the states of matter are important. Now, also important is how exactly does this happen. I mean, if you think about it, I mean, you're not going to usually see something like a liquid randomly turn into a different form, especially gas form. It does happen. Evaporation happens, but there's usually something that makes it happen, and that's the next part. These are the catalysts. So for example, for this one, we need to have 500 degrees Celsius plus a zeolite catalyst. Catalyst, which is anything that speeds up reaction. So make sure to write any catalyst. So third most important part when it comes to third part when it comes to writing equations is write the catalyst, or anything that speeds up the reaction. In this case, there's a catalyst, a zeolite catalyst, and 500 degrees Celsius, and you write that on top of the arrow itself. That means we need these things to make that chemical reaction happen. Now there's also another part, which means in this case it says write word. So here's our word, decane, octane going into ethylene, but we also need to be able to write formula equations, and that's the next part. So and this with this, these are all, so octane and decane are all alkenes, or sorry, actually alkanes. And you might remember, but this is the formula for alkanes. It was CN H2N plus 2. And all that means is if, for example, we say, we should know that, meth is 1. So meth stands for 1 carbon, and oct stands for 8 carbons. If we say, and in this case, we don't need to know that, but dec stands for 10 carbons. If we want to know the chemical formula for a decane, we know that, okay, because of that A and E in the end, it's an alkane. And because of that dec part, we know it has 10 carbonate chain. So that makes N here a 10. So we would write C10. And now we know the N for here as well. So H 2 times 10, 2 times 10 is 20, plus 2. That's how we get our H's. So this would be H22. And now we've actually gotten our chemical formula for decane. And we can write that here. So just because this is actually, we need to be able to write chemical formulas. Now usually you don't actually have to get it this way. This is just showing you how we get it from alkanes. But in most cases they're given somewhere and you can just remember them. But we can also derive them ourselves. So this was decane, and if we do the same formula for octane, I'm not going to do that now, but to save time, but octane would be C8 H22, that's for H18. And ethylene that's an alkene, not an alkane. That would be C2H4, and you're going to find out a lot about ethylene. So I'm not going to talk about it right now much in this video, but you're going to find out a lot about ethylene in next videos. But next part is we're actually going to make sure it's all balanced, because matter can't be created or destroyed. It's always going to be just things changing from one form to the other. So we have to see that the carbons are all equal. In this case, we have 10 carbons on the reactant side, 8 carbons here, and 2 carbons there. So that means 10 on the products. So that's balanced. Here we've got 22 carbons here, 22 hydrogens here, and we've got 18 plus 4 on the product side, and 18 plus 4 is 22. So this is all balanced. Right? So this is good, this makes sense. So the next part is, the fourth important part, is make sure it's balanced. All chemical equations should be balanced. I'll show you what I mean by showing you a non-balanced equation. So imagine all this here to be next part. So now we've produced ethylene. We've produced ethylene by cracking decane and producing ethylene. That was our first step. But now we can actually use ethylene to produce plastics. And in this case, we've got ethylene right here. And when we react ethylene with chlorine and oxygen, we create something called vinyl chloride. Right? So this is a monomer which will form plastics, and you go over that in the next couple of videos. But we have this vinyl chloride forming and this water forming. And these are the chemical equations. That was a word equation on top, and these are the chemical equations. Now, what springs to mind, or what you can see quite fast, is here we've got 2 chlorine atoms, and here we only have 1 chlorine. So I'll show you what happens. This is just a quick animation of what happens if this were the case. So here you have 1 ethylene, and 1 chlorine, and 1 oxygen, which we have in our reactants. Now they all come together and form new products. But the problem is that what we have now is we do have our vinyl chloride molecule, which is at C2H3Cl, but we also have 1 chlorine and 1 oxygen molecule left over. We don't have H2O. So this is not balanced. This didn't work out. This is not what we want. So what we can do is we can just balance it by putting out, for example, we put a 2 in front of here, we put a half in front of here, and a 2 in front of here. And what you can see now is, let's do that again. Let's have our this time 2 ethylene molecules. We have our chlorine molecule and only half an oxygen molecule. They all get to react together to form the new products. And now we have 2 vinyl chlorides and 1 water molecule. And now everything works out. So this is here, it's balanced. So that's the reason why we want to make sure it's balanced, because if it's not balanced, it just doesn't work out. It doesn't happen. If we only have one of each, we wouldn't be creating our water molecule, which is important for this reaction to happen. But if we have just a few more of them, different ratios, that's what we're figuring out when it comes to balance, different ratios, then we can make sure that it all happens as it should. Right? So I'll quickly go over again the most important parts when it comes to chemical equations. So we have to list the reactants and products. We should always have our arrow, which will indicate that a chemical reaction has occurred. We should name the states of matter. So for example, is something a gas, liquid, aqueous, or a solid. Write any catalyst or anything else you need to make sure that chemical reaction actually happens. So for example, temperature, pressure, or catalyst. You write that on top of the arrow. And make sure it's balanced, because if it's not balanced, then the chemical reaction itself wouldn't happen. And also, because what you need to know these chemical reactions for your actual HSC exam. And if you guys would be interested, what I could do is I could make a new video eventually, and just have for maybe every module, have all the chemical reactions that have been encountered in that whole module, and put them into one video, just for you guys to get an overview of what kind of chemical equations you need to know. But leave a comment in the actual video below, and to tell me if that's a good idea. If you want to have one of those kind of videos that goes for every single chemical equation that you should know for your HSC exam. But yeah, hopefully this video was useful.
Thank you for watching.